let's just go ahead and start off with your background. Maybe tell us a little bit about yourself.
Okay, sounds good. Hi everyone, I'm Akari. I'm a research scientist at the Allen Institute for AI, Seattle, and I will be joining Carnegie Mellon University as an assistant professor next year. And I just finished my PhD in computer science and engineering at the University of Washington. And before coming to US, I was born and mostly raised in Japan, and I did my undergrad in electrical engineering and computer science at the University of Tokyo. My area is mostly like NLP, natural language processing, and machine learning. And recently, I've been focusing on large language models, particularly like building augmented language models, like retrieval augmented language models or agentic system that where we design, train, and deploy language models in conjunction with other complementary modules to go beyond their built-in capabilities.
Awesome. So maybe tell us a little bit about how you first got interested in computer science.
Yeah, my path into computer science was a little bit unusual. So in my undergrad, the first 2 years, we don't have any formal majors. So just like broad categories like science, engineering, or like humanities. So I wasn't sure what I was most interested in back then. So I explored like many different areas like economics, stat, law, and political science. But even like I didn't like really explore like engineering area back then. And after the first 2 years, I first majored in economics and focusing on microeconomics. But at some point, I became a little bit unsure whether I wanted to continue in that field longer term. So during my studying abroad in my third year, I took my first, almost like very first computer science class. And like I learned how to program. And somehow like I got really into computer science and programming. And then I started like learning a lot outside class. And after my studying abroad, I also got internship at Google Tokyo, and I really enjoyed the experience. So after that, instead of going back to my original department, I decided to change my major to computer science, and I think it was one of my best decisions in my life. But as a result, I feel like I started programming much later than like many of my friends.
Hmm. Gotcha. Tell us a little bit about your time, choosing to get a PhD in the first place. Sort of what drove that? Were you involved with research during undergrad?
Yeah, so I did some research project during my undergrad. But at the beginning, I was a bit no, like I was unsure like if I want to be researcher or like if I want to do PhD because
Hmm.
I was more interested in just becoming a software engineer and like
Hmm.
work on like product development. But I did some like small research project at universities and also some research group. And I realized that like I liked research even more than software engineering or like development in general.
Hmm.
I think research for me, like research is feels like much more open-ended.
Hmm.
Like we usually cannot find answers in like Stack Overflow or
Hmm.
like GitHub. And like we needed to explore like many different possibilities. And like sometimes like we find like pretty unique or like innovative solution which we've never thought about.
Hmm.
Um, for me, it's that's why like research is more something like more difficult or like challenging. But I
Hmm.
really enjoy this kind of uncertainty or like open-end nature of research.
Hmm.
So after several projects, I decided to do PhD.
Hmm.
And for me, the difficulty was in Japanese undergrad, it wasn't that common to do like actual like research project.
Hmm.
Like we do research project in the final year of undergrad, but
Hmm.
it's still like it's kind of like late for
Hmm.
PhD application. So I remember like I was so nervous when I was applying for PhD.
Hmm.
Lucky I got some offers, and one of them was from UW with like my PhD advisor Hannah.
Hmm.
And I was really interested in how research back then, so I was like, oh, like yeah, like I should definitely go to UW. So I decided to go to UW PhD program.
Hmm.
Yeah, I had like amazing time at UW and was my advisor there.
Awesome. Tell us a little bit about your experience, during your PhD. What are some of the things you learned?
I think I learned so many things. Mostly because, as I said, like I directly came from like undergrad and like during undergrad, I didn't have that much research experience. So like my advisor and also like mentors from internship told me like a bunch of like how like fundamental research. I think especially for my first two papers, my advisor was so hands-on,
Mm-hmm.
and like she like literally gave comments on like every single sentence in my paper, and like I learned a lot from like those really hands-on advising.
Mm-hmm.
And also, one thing I learned during my PhD, especially towards the end, is that sometimes the most impactful work just takes much longer time.
Mm-hmm.
For example, like my most cited paper, we started working on the project, and then like there are so many like difficulties. So eventually, like the paper, it took like 1 year to publish the paper. The paper like got like oral presentation at iCareer, and also like a lot of like community engagement. Like the certificate has been integrated into like many different libraries or used in like other industry applications.
Mm-hmm.
So I was like, when I was working on it, I was really nervous because now the field moves so quickly. So I was like,
Mm-hmm.
oh, like someone will definitely like try the same idea and like will publish paper faster than me. But I think sometimes it's helpful to like slow down and take time and like think about what most important thing is, or like what the challenge we have to work on, and then like spend time and like make sure like everything is correct.
Mm-hmm.
And being patient is one thing I learned, especially like, towards the end of my PhD, because earlier in my PhD I was more like focusing on like just finish the project and start the next one.
Mm-hmm.
um, so that's one thing. Another thing is that um, my mentors always told me like I have to think about impact of the work, not only just publication,
Mm-hmm.
like what, like how people use those methods, or like in longer term, not only just like for next conference deadline,
Mm-hmm.
or like how those systems can actually impact the world.
Mm-hmm.
So another paper I had last year is Open Scholar, which tries
Mm-hmm.
to build retrieval augmented language model for scientific research understanding.
Mm-hmm.
And this project also took 1 year because we had to like train, we wanted to train fully open retrieval model, language model for this area.
Mm-hmm.
And we didn't have any evaluation benchmark. We didn't have like processed open data store, and like we don't have like supervised training data for retrieval system language model. So we needed to do like everything for the project. And like once we had good models, my mentor says that, oh, we also needed to have a public demo. Then like people can interact with this system. I was like, oh, like it's gonna be another 2 months of work.
Mm-hmm.
But we eventually did it. And hosting public demo was actually quite helpful because now people can actually try the system. And I got so many messages from people outside computer science who tested the model and say like, oh, this doesn't work out in my area because many papers are like closed source, or like, oh, like this actually worked out, and like I wanted to like try more. And it was so encouraging. And also because we had this public demo, we also created a bunch of user queries because we ask users if they want to share or not. And I'm actually like using those like real world queries to build like even stronger system. So it took longer than I expected, and I was like doing job search, so I was really nervous back then. But it was really, I think eventually like things worked out, and so I now like I'm trying to think about how we can maximize the impact of work, and like how those like papers can actually like impact the society. And those things I didn't learn earlier in my PhD, but like I learned like towards the end.
Mm-hmm. Awesome. So sort of moving forward, you've worked on a lot of really, really exciting papers. Maybe we can start with one of them. So maybe tell us about, a paper that you're really excited about that was, an important part of your PhD experience.
Mhm. Yeah, I think one of the uh, turning point for me during PhD is a paper called like When Node Has to Language Models. And basically the paper is one of the earliest work that combines retrieval model with off-the-shelf language model like GPT-C. And we started working on it in like 2022. And so like it's like after, or like the year like ChatGPT was released, but like it's around the time where like people in the NLP community knows language models, and like also like the general population like discovered the concept of language model, but still we don't have like really good understanding of like how those language models work, or like when they don't work. And the concept of the paper is basically like trying to understand when language models hallucinate and like how we can mitigate those factual inaccuracy in language model output. And we tried to we basically built a benchmark and then like we evaluated different models performance across different levels of popularity. And what we found is that language models already memorize tons of knowledge, but those knowledge is typically like really popular one. Like for example, like model definitely know like the capital of Japan is Tokyo, but like it doesn't know long tail knowledge, like knowledge that is underrepresented during training time. So like the model doesn't know like who Akari Asai is. And so like even like the best model, I always test like, oh, who is Akari Asai? And half the time I got like answer like Akari Asai is a Japanese actress or like anime character, those instances. And for that, we found that retrieval augmented approach is quite helpful. And surprisingly, we can just take off-the-shelf language model and retrieval models and then like combine them at inference time. And by doing that, we can reduce hallucination like, I don't know, 50%. And so I got really excited about retrieval augmented language models because it's kind of an area I've been working on. But I was getting like kind of unsure, like, oh, now everyone is working on language models. And like, should I keep working on like this retrieval or like question answering area? But like, it turns out this is actually core technology to improve language models. So I decided to like focus on retrieval augmented language models. So we had a tutorial on that year at ACO, the one of the most major conference in NLP. And also I worked on follow-up work, Certifrag, based on the finding of this paper. Because one key finding from this when not trust to language model is that although retrieval is quite helpful, if we just take existing retrieval model and language models, retrieval can sometimes negatively impact language model. Like retrieval system is not always perfect. So it can retrieve like unhelpful documents. And language model can get confused because of those unhelpful documents. Or like sometimes language models already memorize knowledge. So we don't want to like retrieve like obvious fact. Like for example, like when we ask a question like what the capital of US, like the model should definitely like the capital of US is DC, then like we don't want to like go to like Wikipedia articles and then like retrieve and improve the attention. So I wanted to build more like adaptive or flexible retrieval augmented generation system. And Certifrag basically teaches the language model to decide when to use retrieval. And then like once we retrieve documents, it also evaluate which citation documents are the most related to the questions. And then like the model generate answer and the model after like self-evaluate if the model generation is fully supported by citation or like if the quality of generation is high enough. And back then like I was like, oh, like this was kind of like a straightforward idea, but it turns out to be quite effective approach. Like for example, we tried 8B and 13B language model, like fine tuning, and we found that this fine tuned model can easily outperform like proprietary language model with retrieval because now we train like language model in the new recipe so that those model can more effectively and efficiently incorporate retrieval. And yeah, those are the two papers that kind of like convinced me that like we should keep building like language model in conjunction with other external like modules like retrieval system or like make sure like those build a like language model based system where like multiple components work together to enhance the model predictions. And so I've been working on this direction, and like recently I got also interested in like how we can apply those system to new like expert domains area or like real world problem. So I've been interested in like building those systems for like scientific domain or like code generation.
Awesome. You have a lot of other papers that you've worked on. Maybe tell us a little bit about, you sort of covered when not to trust language models. Maybe tell us a little bit about CodeRag Bench, Open Scholar, SelfRag.
Yeah. So CodeRag Bench and Open Scholar are the papers where like we tried to evaluate or like build those retrieval augmented language models for expert domain, like code generation domain or like scientific applications. And the thing is that although like there are many retrieval augmented language models paper, many papers focus on like general domain factoid question answering setup, which is challenging, but also like it's one of the cleanest setup. Like the questions are like just about factual knowledge, and we can easily find answer from, I don't know, like Wikipedia. But when it comes to, like, for example, building like code retrieval augmented generation models, the question is like, oh, like how we should even build data store? Like what kind of data store could be helpful to enhance code agent? Or like how we should process those documents? Because like in normal Wikipedia-based question answering, we can simply like split each article into like every 200 words. But like in code generation scenario, we usually needed to maintain like semantic unit, like file names or like function or like how or like consider like those structure of code bases. And those things are underexplored in the community, mostly because many papers focus on like more like factored like general domain question answering setup. So I felt it's important to explore like how those retrieval augmented generation, the state of that models can perform in those expert domain area. And Code Workbench is basically trying to combine existing code generation benchmark and also data store to show like what challenges we still have in code retrieval augmented generation scenario, or like how well existing models perform in those diverse setup. And another another type of this kind of more like application or like goal-oriented research I had last year is OpenScatter, and this one is again like we don't have good benchmark, good training data, so we tried to like first build a data store, explore like the way to train and evaluate models, and those work typically require larger collaboration. For OpenScatter, we had like 20, 30 co-authors from like 7 different institutions, mostly because we wanted to make sure we have good benchmark to evaluate the model across many different areas, not only just computer science. So I had collaborators from like physics, bio department, who can help us to evaluate those models. And for public demo, we also had people who are more focusing on HCI so that we can have nice system that can help users to interact with those models.
Awesome. Maybe tell us a little bit about some of the, some of the lessons you've learned throughout your time working on research. Obviously, you learned a lot throughout your PhD. You've also learned a lot through these collaborations.
Uh-huh.
What are some of the things that you've learned, and also maybe tell us a little bit about your time at AI too.
Yeah, that's a good question. I think in terms of collaborations, I, especially like towards the end, I had multiple papers where I have many co-authors, like collaborators, and what I learned is that, especially for large scale collaboration, the important thing is that one, like whenever like we invite new people, like try to uh, clearly communicate what we expect them to do, or like how I believe they can contribute to the project. Because something like people wanted to help, and I also like want to help, but like I didn't like communicate enough, and like people were kind of like not sure like how they can help. So I always try to make sure like, oh, this is a project and this is an idea we are kind of struggling, and like this is where like I want your help. Another thing is that I also try to I I think it's really important to have pretty good first meeting and like tell like the impact of the research, the project we are working on, because people are just like so busy, and like something like people can't spend enough time for like each collaboration project. So I wanted to when I, especially like when I need help from my collaborators, I try to make sure like this is a project, this is the impact I think, this is like the impact I can think of, and like I believe like this is gonna be like important work not only for me but like for the community, and I need your help. And those things I'm still learning, but I think communication is quite important for those large scale collaboration, and sometimes it takes time. But I think those, especially like interdisciplinary collaboration, I really enjoyed it because I learned a lot of new perspective from people outside computer science, NLP, and also I quite enjoy working with many different people. And yeah, and another question is AI too. Yeah, I joined AI too in at like late July. I think it's interesting feeling for me because I've been at UDA for like 6 years, and now like I've been kind of like working with people whom I already kind of known, because AI2 is in Seattle and we have really close collaboration between AI2 and UDA. But still like I'm learning like some new skills. For example, when I was a student, like I was a first author always, and like I was leading the
Mm-hmm.
project. But
Mm-hmm.
now, like I feel like I'm expected to be more like mentor, like manager. So they're like a new thing I need to think about. But it's exciting to see like something I've never learned, and I'm also like enjoy working with students who are really excited about the project, and also like who are like more experienced these days, like because they know like everything of the state of the art models. And I believe AI2 is a really nice. It provides a really nice environment. One challenge I had when I was doing job search this year was like many industry research groups now kind of stop publishing papers when papers on like core language model techniques because it's becoming a like competitive advantage of them. And for me, I love publishing papers and I want to share my knowledge with other people. And because like I hope that it will help other people's research or like product. And many industry research groups now they have some kind of restriction on what we can publish. Well, like at AI2, they don't have like any like publication restriction right now. And also I can explore like my own research direction. And so I've been really enjoying the environment. And still like so for me like it's still feels of like mixture of like academic and industry research group, but still like they have more compute because now like they have organization level goal to build the best open language models. But I had pretty so far like I've been having a great time at AI too.
Awesome. Maybe sort of our last question here. Thinking about your time back when you were an undergrad or you were a PhD student, and now you're going to be joining CMU as a professor eventually. What sort of advice would you give to students that are thinking about becoming professors, thinking about doing research? Like, what are some things that you wish you knew?
I wish I knew. I think one advice is maybe find our own interest or like find like what excites us most. For me, I've been kind of working on the same thing for like 6, 7 years now, and my interest or like passion is basically like trying to build models or like language technology that can help people to access the information they need. And so it could be a form of question answering model. It could be like retrieval augmented language models. But fundamentally, it's like my research is like all based on this longer term interest. And for me, having this strong interest really helped me during my PhD because during my PhD, the field changed a lot. Like NLP was when I started working in research, I was initially in computer vision group, and then like I studied PhD in NLP, and like people kept asking me like, oh, why not working in computer vision? Because it's more popular. Back then, like it was more popular.
Mm-hmm.
Like everyone is working on like semantic segmentations, diffs estimation, those tasks. Um, but I decided to just work on whatever I'm interested in, and fortunately, like the field got there were a bunch of changes, so it's kind of it was difficult to navigate. Also, like it was half of my PhD was during pandemic, so there are like many challenges. But for me, like it was really helpful to just focus on my own interest. Still, like I try to consider like what other people are interested in, but having this kind of my own interest helped me to focus, like keep having some kind of like underlying theme on my PhD, and this turned out to be really helpful when I was working on my job search. And I think now it's getting more and more difficult to navigate for new PhD students or like undergrad students because there are so many people who are interested in this area and like many people are interested in like working on similar ideas. So we are always like having the pressure of like, oh, like I might get scooped or like, oh, like how my work is different from others.
Mm-hmm.
But I think thinking about how what we are interested in, like how what make our work unique could be helpful, and also like don't worry too much about getting scooped and like
Yeah,
spend time. Yeah.
that makes sense. Maybe one very, very, very last question. Are there any areas that you're really excited about these days? Like, obviously, a lot of people are talking about RL environments. There's a lot of like basically everyone's talking about RL. You spent a lot of time in LLMs. I mean, a lot of people are talking about LLMs too. A lot of people are talking about
Yeah,
RAG, which you've also worked
yeah.
with. So maybe aside from all the buzzwords and all the hype that everyone is working on, like, are there any specific research directions that you think that are really exciting? Like, what are you excited to work on in the next few years? Like, what do you think more people
Yeah,
should care about?
yeah. I am longer term. My research vision is like how we can build language models so that it can more effectively and like efficiently use other modules at inference time. For example, like how we can build language model to use like external tools, or like how we can like build a multi-language model inference system so that like we can offload more like expensive. We can offload like some easy tasks to smaller model, or like harder, more challenging tasks to like more expensive models. Those things, and in those areas there are many challenges. For example, like how we should design better training, like training with external tool codes, or like training with multiple language models, or like how we should design better inference, which could be like NLP problem, but also like MLC system level problem.
Mm-hmm.
And particularly like in those areas, I think actually like auto is quite exciting right now.
Mm-hmm.
And so I think it's one pretty powerful way to make language, especially in the context of this augmented language models, auto could be one powerful way to teach language model to explore like many different possible approach, and then like generate reach out the answer. Like instead of like just generating from language model, we can make language model to use many different tools, or like interact with other language models, and then like finally the model sample many different possibility, and then like picks the best response. I think it's exciting. The one area I feel is missing right now is that many of RL papers focus on like verifiable task,
Mm-hmm.
um, math and code, and those areas it's still like difficult to make it work. But we can also like verify like correctness of the response, so that helps us to scale up training data, or like do like online RL using this verifiable reward. But in many applications, especially like ChatGPT type, like
Mm-hmm.
those chat applications, many tasks are not verifiable, or like semi
Mm-hmm.
verifiable maybe.
Mm-hmm.
And so like those long form responses, we don't have still like we don't have like any good way to evaluate a trained model in an end-to-end manner. Like there's some RE paper, but still we don't have good consensus of how we should train model end-to-end using auto when the task is not fully verifiable. And I think this area is quite exciting. And for me, it's even more relevant to what I'm interested in, because in retrieval language model, one of the biggest excitement is around deep research system.
Mm-hmm.
The existing deep research system, open deep research system,
Mm-hmm.
none of them are trained or evaluated for actual long form unverifiable task, and there are still many open questions on how we should train those models, or how we should evaluate those models. So that's kind of immediate interest I have right now.
Mm-hmm. Awesome. Well, thank you so much for coming on the podcast. Really appreciate it.
Thanks so much for inviting.